In this chapter, we also cover heterocycles and determining whether they are aromatic or not. And so for this one, this is pyridine, and we're going to see if this molecule is aromatic or if it is not aromatic. So to begin, we want to discover and figure out how many pi electrons there are. Okay, and so if you take a look, we have 1, 2, 3. So we have 3 double bonds or pi bonds in the ring, which is going to equal 6 pi electrons. Okay, so we also have to consider the this lone pair that's sitting out here, and we have to assess whether it's part of the pi orbitals or it's not. To do that, you have to know that when an heteroatom is attached to a carbon, it takes on that same hybridization. So all of these carbons are sp2, okay, all the carbons in the ring, which means that this nitrogen is also sp2. Now what does sp2 mean? Okay, so sp2 means that you have 3 orbitals that are hybridized as sp2. Okay, you know that because the number of orbitals you put in to hybridize is the same numbers you get out. And so we have 1s and we have 2p orbitals. So 2 times p, 1 times s. Okay, so that comes to 3 orbitals. Now, you also have to remember how many p orbitals each shell can have. And that is 3 p orbitals per shell. Okay, so if there's 3 p orbitals per shell and I've only used 2 to hybridize, that means I have 1 free p orbital in the nitrogen. Okay, now is it really free though? Okay, so where is the p orbital? If we look here, we see that there's a n double bond C. Okay, that tells you that the nitrogen's using its p orbital. So if the nitrogen is using its p orbital, the lone pair on the nitrogen in this situation, in this molecule, is going to be in a sp2 hybridized orbital. Okay, and now sp2 hybridized orbitals do not play a role in making double bonds or pi bonds. And so we know that this set of lone pairs, these 2 electrons, are not pi electrons then. So that just allowed us to identify how many pi electrons there were in the molecule. I'm now going to erase or work down here and go to Huckel's rule. And so Huckel's rule is 4n plus 2, and n needs to equal a whole value. Okay, and so we're going to set this equal to the 6 pi electrons. You're going to get 4n equals 4, and then that gets to n equals 1. And so we come to the conclusion that this molecule is aromatic. Okay, and so that's how you assess heteroatoms. Looking at a different heteroatom like I did in the notes, let's look at pyrrole. Okay, now pyrrole, we're trying to figure out how many pi electrons there are to help us calculate Huckel's rule and determine if this is a aromatic molecule or not. Okay, so again, each carbon in this ring is sp2, which means that the nitrogen is also sp2. So again, we have 3 hybrid sp2 orbitals. And remember, these hybrid sp2 orbitals, they are going to do sigma bonding. They are not going to do pi bonding. So let's assess the nitrogen and see what those lone pairs, what type of orbital they're in. Okay, so if you look at nitrogen, nitrogen has 3 bonds to it in this molecule, and they are all sigma. Well, that should tell you right there that these lone pairs are in a p orbital, because you already assessed that this nitrogen only has 3 hybrid orbitals to use, and it used them already in the molecule. So you can see there's a sigma bond, sigma bond, sigma bond, and they're all attached to the nitrogen. So that means these electrons right here, they are in a p orbital. Okay, and again, that goes back to the fact that you should have 3 p orbitals in every shell, and you only hybridized 2 of them, leaving 1 available. So if that, or those lone pairs are in a p orbital, that means we can figure out the number of pi electrons. And so the number of pi electrons is going to be 6 pi electrons in this molecule. So when we go to Huckel's rule again, 4n plus 2 equals 6, you're going to do the same calculation and end up with n equals 1. And since this is a whole number, this tells us that this molecule, pyrrole, is also aromatic. Okay, so heterocycles are a little tricky because you have to assess the hybridization of the element or atom in the ring. That's the heteroatom. Remember that heteroatoms take the same hybridization that the carbon that they're attached to is. And so you can go ahead and then do like an elimination type of workup like I did, where you know that you have, if it's sp2, you have 3 hybrid orbitals. Do you see 3 sigma bonds? Then those lone pairs are going to be in a p orbital. If you don't see 3 sigma bonds and you see 2 sigma bonds and a pi bond, like in the pyrimidine example, then you know those lone pairs are in a hybridized orbital.